Recording is on.
Okay, we are now recording. Thunder Biscuit, do you want to kick things off before I start my spiel?
Yeah, hello everyone. Welcome to the second meeting of the Mastering the Lightning Network book reading club, I think is the formal name. I want to start by saying thank you to Alexa, who provided a sick-looking logo free of charge, just because she's awesome, and it's now on the webpage. We're gonna link the webpage here in the chat, so you can access it. But then otherwise, sorry, it'll take me a second to get that going. And so the way we're doing this is every week we're hoping to have sort of a host for that week who'll be walking us through the chapter a little bit more, or taking the lead for that particular chapter. And this week we're doing chapter 3, and Stephen is doing the lead for chapter 3. So take it away.
Thank you. All right, let me go ahead and get my my screen share situated right here. Start window.
And I'm going to interrupt Stephen here.
Go for it.
Just letting people know that we will, as a compromise as far as an open source community, we will be recording part of this, and then we'll be shutting off the camera and also having a little bit of extra discussion afterward for those people who may not feel as comfortable with the recording. That's it.
Thank you, Alexa. Good. Yeah. After all the discussion we had around that would have been silly if we had forgotten to talk about that. So so we're on chapter 3, how lightning works, and we had a good bit of a pre-call discussion here, and so we might not. I want to go ahead and say that this chapter is a very, very long and lengthy chapter. And one, just because it's so long and because we had a little bit of pre-call discussion, I do say that at the end of this call, we may want to decide if we want to spend another week on chapter 3 or if we all feel comfortable moving on. So let's just see how we feel about that. Yeah, so I put together just some, notes that I thought, that I kind of collected about this chapter. So it's how lightning works. I'm also leading this chapter for the Atlanta meetup as well. I just want to go ahead and take a note that we do talk about some stuff here that's kind of specific to layer 1 Bitcoin. And so if there's any concepts in this chapter that you didn't understand, I'd really recommend you go check out Bitcoin book on GitHub. That's the other one that comes before this, Mastering Bitcoin. So there may be some chapters that if you read in there, it'll help some more concepts in this book make a little bit more sense. But just to give you like a brief overview of what I'm going to go through here, just talk really briefly about what the Lightning Network is, compare it to Lightning to Layer 1 Bitcoin, talk a little bit about payment channels, a little bit about invoices, and a little bit about payments. And I want to go ahead and invite you, if anybody has a question, to just interrupt me. If you think, the only thing I'd ask is just, try to keep in mind that this is kind of the topics we're going to go through. So, just think about where your question kind of fits in here into this paradigm. And like I said, just feel free to interrupt if you think that, the question's relevant to whatever we're talking about. And then once I'm done, like Alexa said, we're just going to have some kind of real open, unrecorded, free conversation, if that suits your needs. So I'm pulling a lot of these just kind of quotes from the book. What is the Lightning Network? It's a peer-to-peer network of payment channels implemented as smart contracts on the Bitcoin blockchain, as well as a communication protocol that defines how participants set up and execute these contracts. So that's a mouthful, but hopefully we'll all understand that a little bit better as we discuss this together. So I just want to really rapid fire here, just go through some comparisons with Bitcoin, because I think that these are comparisons that I just pulled from the book that I thought were really simple and easy to help the mind think about the differences between the two. So in Bitcoin, we create a transaction. In Lightning, we send a payment. We're going to see those terms thrown around a lot in this chapter. In Bitcoin, we send to an address, where in Lightning, we pay an invoice. In Bitcoin, we have to select outputs or select UTXOs that we want to spend, whereas in Lightning, we have to find a path in order to make a payment. In Bitcoin, we have change outputs. So when we spend our UTXOs in Bitcoin, there's an output that we send to somebody and then a change output that we get back. But in Lightning, there's no change at all. In Bitcoin, when we do a transaction, we have to pay mining fees. But in Lightning, when we make a payment, we have to send routing fees. In Bitcoin, the fees that we pay depend on the traffic of the network, whatever the traffic is at that time. But in Lightning, the fees are announced, and we know exactly which fees we're going to be paying, or our node knows the fees that we're going to be paying. In Bitcoin, transactions are public; they're all on the blockchain. But in Lightning, payments are private. In Bitcoin, we have to wait for confirmation. In Lightning, there's instant settlement. In Bitcoin, the amount that we can send is only limited by the amount of UTXOs we have, whereas in Lightning, the amount that we can send is only limited by our channel capacity. In Bitcoin, we have incentives for large value transfer, and in Lightning, we have incentives for small value transfer. And I said that, you notice I omitted the word transaction and payment there just to make that more symmetrical. In Bitcoin, we use the blockchain as a ledger, whereas in Lightning, we use the blockchain as a court system, which to me was a really compelling idea. I like that one a lot. In Bitcoin, it's asynchronous. You can send payments, offline in a sense, whereas in Lightning, payments are synchronous. The sender and the receiver have to be ready to send and receive at the same time. In Bitcoin, we send satoshis. In Lightning, we can actually send millisatoshis, which I'm curious to learn about later in the book. So those are just some kind of like rapid fire, quick differences between the two. Does anybody have any question or discussion they want to have around that before we discuss payment channels? Cool.
Just wanted to reiterate that the idea of the Bitcoin blockchain as like the court of law for Lightning has been very helpful for me, and I was glad to see that pop up here again, because that's a big part of how I think about Lightning.
Yeah, it's very fascinating, and especially thinking about the court, it's like we don't typically think of a transaction in a ledger as being something that can have like logic built into it. But as we'll see as we get deeper into this chapter, you can actually cram a good bit of logic into these transactions. And a transaction that's recorded on the Bitcoin blockchain can have a lot more data encoded into it, can have far more data encoded into it than just this amount goes to this address. So it's very interesting stuff. So kind of on to our next topic here is payment channels. There's a lot of time spent discussing this topic in the chapter. I do have a Lightning book chapter 3 open in this other tab, so if we need to quickly swap over and get any information for anybody, we can do that. But a payment channel, what is it? So it's a financial relationship between Lightning nodes allocating funds from a multi-signature address through a strictly defined cryptographic protocol. So basically what that is you and your channel partner. So Alice has a node, Bob has a node. Alice and Bob negotiate a sequence of transactions that spend from a multi-signature address. And instead of recording these transactions on the Bitcoin blockchain, Alice and Bob are just going to hold on to these transactions unspent. And I know we don't need any more comparison to drugs or illegal activity in Bitcoin, but I couldn't help it. When I hear that, like, we're negotiating, it really makes me think of like any movie that you've ever seen where there's like two criminals performing a deal, or it's like a hostage situation or something, and people are always like trying to think about like, how do you complete the deal in such a way that, you know, nobody can like renege on their obligations. And so this is just a screenshot from a funny episode of Better Call Saul, where there's a, you know, crime deal happening. But you got to think, I think of it in my mind almost as like, you know, somebody's got, you know, the bag of diamonds and somebody else has the bag of cash, and they're in some, you know, seedy factory. And it's like, okay, you drop your bag on the conveyor belt, or we're both going to drop our bags on the conveyor belt at the exact same time and, you know, push a button to send the, you know, the valuables towards each other at the same time. That's not an exact metaphor, but I really do think of lightning in the sense of that, like each node is kind of negotiating with the other node and trying to make sure that, you know, neither one of them gets burned on the deal. So there's a lot of math and, you know, complex cryptography and game theory, but just at a high level, I think about it like that. It's a negotiation. I want to briefly talk about multisig. So I'm kind of going downwards in my slides here just because it's kind of a tangential topic. I think a lot of people here are probably familiar with multisig, but I just want to very briefly cover it. You know, we think of, you have a wallet in Bitcoin, you can send to an address, you can receive to an address, but you can do something pretty clever in Bitcoin called multisig, where you basically have, you know, like multiple keys, multiple private keys that that you know, are capable of spending from an address, right? So you might think of this as being like typically like 2 of 3 multisig is something you might commonly see to kind of protect your funds. So you have 3 keys, but you only need 2 of them to send. But in Lightning, we use a 2 of 2 multi-signature address. So in Lightning, in summary, as they say in the book, a multi-signature address is where Bitcoin is locked, so that it requires a multiple signatures to unlock and spend. And a 2 of 2 multi-sig address, there are 2 participating signers, and both need to sign in order to spend the funds. So with your Lightning multi-sig address, Alice has 1 key and Bob has the other key, and it requires their cooperation in order to spend both of them. So before we move on to payment channel transactions, does anybody have any questions or discussion points regarding just the concept of a payment channel and the fact that it uses a multi-signature wallet to negotiate an agreement between Alice and Bob?
You know, I was just going to comment that the way that it's helped me picture kind of like channels and how you open them up and stuff like that, it's more of the association with a subway. So I'm thinking of the nodes being a different station and the channels being kind of the tracks, and not knowing, like needing extra tracks depending on the different stations and kind of the subway growing. So if that helps anybody think of this.
Yeah, I think that's a good metaphor, and I think that will be a especially strong metaphor when we start talking about like the pathfinding and the routing and all of that. That it's like, yeah, you need enough train tracks to get from one place to another, or you need enough. I think that's a great example, Alexa.
Probably worth mentioning too that even those user multisigs, it's not really a multisig wallet as much as like a multisig account. You know, like a wallet can have multisigs and single sig outputs in it. Just kind of clarify that point that, you know, it's a sort of on a per output basis, which is, you know, kind of an interesting detail.
Yeah.
Building the wallets.
No, that is a good point. Thank you, Steve. And yeah, I'd like to elaborate on that. Like, sometimes I know in Bitcoin, I guess we tend to use the wallet to mean 2 different things. And this is something I kind of learned reading Mastering Bitcoin, is that, it's like we have, as designers, we think about a wallet as like, okay, this is an app that I use on my phone. Whereas then, in on the protocol level, you have the idea of the HD wallet that can, generate like many subordinate key pairs. So like the term wallet, I guess, can mean different things based on whether you're talking about it in terms of like the protocol level versus at like the level of what the user holds in their hand.
Right, and then it actually gets even, just since we're talking about Lightning, it's this whole other idea too, that you can sort of have balances in these Lightning channels or balances on chain, and that could all be considered one wallet in one sense, like the Moon wallet does that. They kind of show you a consolidated balance. So yeah, the word the wallet is a little overloaded these days. But
Interesting.
to clarify that.
Thank you, Steve.
Yeah.
Go for it.
So I was wondering, basically, because I got to the part where they talk about the Poon Dryja channels, the L2 channels, and then the other type duplex micropayment channels. And I wasn't sure, like, because right now there's only one type, but are we saying that eventually your wallet would have different types of channels with different people? And so the roots, connectable, or are those going to be basically 3 different layers of the Lightning network and then you'll have maybe a wallet that uses L2 channels, or could a single wallet use many channels, and then your roots would have to decide, or I'm not sure. I know channels we're not there yet, so those are not implemented, but when that comes, I'm not sure of the mental model there.
I think,
go ahead.
I was just going to say, from my understanding, it's sort of in the transitory period, there would be potential, like your wallet would have the potential to have multiple, kind of like how you can have non-SegWit and SegWit, or like you can wrap SegWit in a Paytas for Hash. In theory, you could have a wallet that supports multiple types, but I think it's the case that they are just kind of significant improvements upon previous types of channels, like pending improvements in Bitcoin's core protocol. And so I think it would be the case that you would likely, if you were starting fresh, then you would always open the latest L2 channels, because that would be better than what we have today, type of thing. And I think one of them is also an older idea type of channel that was never implemented and won't be. It's just like a historical first attempt. There was multiple attempts on how to structure payment channels, and had lots of drawbacks until we got SegWit. And now, once we get Taproot, and I guess I don't even know what L2 else needs, maybe any prevout, but as we get there's these other constructions basically that I think will be strictly better. Like there wouldn't be a reason to have multiple unless you were trying to have backwards compatibility, is my understanding.
Yeah, I do understand that L2 needs a separate opcode that any prevout. So it's certainly a future soft fork would be required for that. And then I think there's maybe even another little gray area here, which is he doesn't mention Taproot or Schnorr signatures, but I do believe that will create a different kind of channel. Maybe he'll talk about it in future chapters, but because there's a way to do these pay to point lock, I think it's called. Maybe that's a future thing he'll talk about, but it's still similar to the channels they have now, but using a slightly different construction that doesn't need any new opcodes beyond the Taproot stuff and the Schnorr signatures.
I just want to quickly mention, probably as far as I understand, the difference between all these mechanisms from what we have right now is the penalty mechanism, like in L2 and that other thing. Basically, in current Lightning Network, we use this penalty mechanism to restrict parties not to publish the previous commitment transaction. So these L2 and duplex channels are basically a new way, or just a different way of doing that penalty transaction. So it probably will also have the 2 of 2 multisig, but it will have a different penalty mechanism to restrict the breach of the contract.
Yeah, I think there might be one thing about that, Raj. I do believe with the Schnorr Taproot stuff, the way channels work today, there's a single channel ID that every node sees that channel ID. But going forward, once Schnorr and Taproot are available, you have a little extra bit of privacy because they're able to construct a pay to, I forget what it is. It's a
Script
it's a
hash.
payment point. It's a payment point, I think they call it.
It's the
Um,
PTLC that you were talking about?
Yes, PTLC, and that's on a hop by hop basis, so it's not shared among all the hops. So there is that. That's not just strictly penalty. It's actually just providing some more privacy hop to hop. So anyway, maybe we're going too deep in the future stuff, but yeah, there's definitely some. He didn't cover all the possibilities maybe in this chapter of what could be changing in the future.
Yeah, and I also think like L2 and like duplex are not yet implemented anywhere. Probably Blockstream was working on some kind of implementation in L2, but I'm not sure. Like, yeah, PTLC and HTLCs are, I think, kind of like similar construction. Instead of hash time locked, you will have some kind of elliptic curve point time lock. And yeah, but otherwise the mechanism becomes the same. In both the cases, the penalty mechanism is like if you put the previous commitment transaction, the cheater will lose all of the funds. And in L2, I think there is no previous commitment transaction, and it works in some different kinds of way, and that's how it breaches the contract. But yeah, I think that's going ahead of ourselves, and we will probably have a lot of room to discuss about the details over next sessions.
I will say that Paul has added something to the chat. He says, thanks to the use of feature flags, and it's a quote from Blockstream, which allow a node to signal support for a new feature when first connecting to a peer, L2 can be deployed incrementally on top of today's network. There is no need to spin up a completely new network.
Interesting.
And he's got a link to Blockstream. Thank you, Paul.
Yeah, but that's still with the caveat that I believe L2 does require some soft fork change to the Bitcoin network. But that's interesting, the versioning system they have. I didn't know about that.
All right. Well, I think I'm going to kind of segue here into talking about the different transaction types that you might encounter with a Lightning payment. Since I think Raj brought up the idea of the penalty transaction. So that's right what we're about to get into right here. Like, notice I say transaction here as opposed to payments. So payments, a Lightning payment, we have to think about is constructed of Bitcoin transactions, not all of which are closed out on chain. So there's different types of transactions that we'll commonly see there. One would be our funding transaction, which is, Alice wants to form a channel with Bob, so she submits funds to a 202 multisig address. The thing to remember with the funding transaction is that it is public on the Bitcoin blockchain, but the payments that Alice makes, having open to that channel, are now private between her and Bob. Now, I thought this was an interesting kind of thing that was in the book, an interesting way of thinking about this. We always use the term locking funds in a Lightning channel, but the authors of the book prefer to portray it as that the funds are unleashed, and that the reasoning is that when you put funds in a Lightning channel, they actually become far more liquid than anything that's on layer one. They can just be spent faster, cheaper, more privately. So you're actually unleashing them in terms of locking them, which I thought was an interesting way of putting it, because I think that the term locking does kind of put the wrong impression in some people's minds, and maybe reminds them of the idea of like staking or something like that on Ethereum. Just the sound of locking isn't always great.
I kind of disagree with this. I understand that we would like to have nice like propaganda and make people feel better about Lightning, but if it's committed to you lock up funds in a multisig, and the multisig is required to spend it, and that just seems like it is locked there. Maybe there's a better term than locked, but unleashed is just seems like spend to me. Like these funds are encumbered, and you cannot do what you would do with a typical UTXO in your normal single sig wallet.
That's a fair point of view, I think. I mean, I think, yeah, I mean, I guess if you were to, say that putting your funds in a Lightning channel is always the best solution would be, like wrong. It's like, I guess there's trade-offs either way, right? If you want to have, you're dealing in large transactions amounts, or if you want to have something in cold storage or whatever, then having it in a Lightning channel wouldn't always be beneficial. But if you do want to make micropayments, then I guess the trade-offs would be worth it. So I mean, I think that's a fair criticism, Paul.
Yeah, I have to agree. It seems like marketing spin, but then on the other hand, they're also unleashed like a pack of dogs that you need to keep an eye on, which you don't need to keep an eye on with the on-chain stuff. But yeah, I agree too.
Yeah, I mean, I guess you got to pay attention to your node, pay attention to your security, make sure your whole network hasn't gotten hacked and all of that, and
these are hot funds that have to be on a kind of a hot wallet. So, so danger there.
Yeah, I guess unleashed can be good or bad.
Isn't the term locked sort of standardized in a way? Like I noticed on DeFi Pulse, they talk about the total value locked, the TDL metric for determining the amount of money that's committed into a particular chain.
I have heard the term like locked, I think, before, like saying, "Oh, it's locked in a contract," and stuff like that.
I suspect this is Antonopoulos's term. I actually hadn't heard it before seeing it here, so it might just be his little term.
I think you can you can see both points. It's like it's on layer 1 they're locked, but on layer 2 they are unleashed. And so the point is you're locking your outputs on layer 1. They can no longer be used on layer 1 without breaking out of the channel. But in some ways you're also unleashing them to be used on layer 2 and everything that provides you. So I think it would be best to kind of talk about it in both ways, maybe.
Well, if you go from one layer to the next layer, you're clearly leveling up. So how about something from gaming? So it's like an improvement, become faster, stronger, better, more liquid, lower fees.
Are you leveling up or layering up?
Yeah, works too.
Oops. We want to give him a chance to rejoin, because yeah, it looks like. Yeah, Stefan, are you there?
We might have lost him. He's setting the bar. Have you seen this presentation? This is
and
yeah.
not to beat a dead horse, but is Hashtime locked contracts. Like these are smart contracts that lock funds under certain spending rules, basically.
Yeah, that's a good point too. Even the point time lock contract, right? Point.
Oh, he was back there for a minute, but now he's gone.
Well, maybe while we're waiting for him to rejoin, anything else to discuss in this nomenclature section? I think.
Hey, everybody.
Oh, there he is.
Yeah, sorry about that. I think my internet flaked out for just a moment, and then my browser crashed after that. So I tell you what. Let me just pull up my thing again real quick here. I am wondering if we're starting to run a little low on time here before I think we wanted to go do the unrecorded segment of this. So I can keep kind of going through the notes that I prepared, but I also before doing that, I'd like to kind of open it up to everybody and see how we feel about the content in this chapter. Just because I know that I've been kind of discussing more, like I've been discussing the payment channels specifically, and there's a lot of other stuff to talk about in this chapter, like invoices and just, how payments are routed through the network, the gossip protocol, and all that kind of stuff. And so I just wanted to get a sense, like, does anyone feel like we need to spend another week on this chapter? Or is everyone feeling comfortable, and would we just like to turn it over to just general discussions and questions people have?
Maybe we can open it up to a vote. Let's see. Happy face is a yes, and sad face is a yes to continuing on to a next week. Maybe a sad face is no, we're good. I don't know.
So let's yeah, I think that's good. So you're saying do a happy face emoji if you'd like to spend another week discussing chapter 3. See how many of those we get. I'm seeing a lot of happy faces here.
Tom Park is saying that he'd like to dig into more details, but he's fine with another week too.
Yeah.
I would like we lost you kind of at a pivotal moment, I feel like, because something I really benefited from this chapter was this distinction of the commitment transaction and the funding transaction. Because I'd heard the term like a justice transaction, which is almost like almost a separate term for publishing a commitment transaction with prejudice somehow. I don't know if you have those slides for those. I'd love to see that.
Absolutely. Let me just pull that back up right quick here. So can everybody see my screen okay? Yep. So maybe what we should do then is it sounds like a lot of people in this room would, or I'm not measuring exactly how many people we have total in here, but it seems to me like a lot of people would feel more comfortable spending an extra week on chapter 3, which I think makes sense because there's so much ground to cover in this chapter, and it might be good to make sure that we understand some of these concepts a little more firmly before we move on to the more advanced stuff. So yeah, maybe let me just talk real briefly about transactions, just so that the topic of payments has basically been completely covered this week. And then we have a clean break to next week to start talking about invoices and, the network and gossip protocol and all that. So like, the basic idea to your question, Paul, about like, I think you're really talking about punishment transactions. So we essentially first we have the funding transaction, which is where Alice actually sends money to her 202 multisig address. Okay. But before she actually submits the funding transaction to the miners, she creates a refund transaction, which would refund all of her money back to her. And she has Bob sign that refund transaction. And so that transaction is signed before she actually funds the address. And she doesn't give that refund transaction to the miners yet. She holds on to that as kind of like a trump card just in case Bob disappears or fails to cooperate. And then we have this idea of the commitment transactions. And each time Alice wants to send to Bob, she and Bob essentially create new Bitcoin transactions that are that adjust the balance that gets paid out of that multisig wallet. And the idea here with the commitment transaction is they're just kind of adjusting the total balance if they decided to close the channel. So per your question about the punishment transactions, the idea there, so the idea is that we have this idea of the revocation secret, and when this commitment transaction, if they were to take the commitment transaction and pay that and close that transaction out on chain, if they did a force close of the channel, one of those transaction, like essentially one of the channel partners would have to wait 2 weeks or approximately, or 2016 blocks in order to get their payment. And the idea here is that what prevents somebody from trying to take a previous commitment transaction and cashing that out instead of the most recent one is the idea that they essentially hand off their revocation secret every time they sign a new every time they sign a new commitment transaction. And that would make it such that if their channel partner decided to close out with the previous transaction, you would have their revocation secret and could swipe the funds before they did. So that's kind of the gist there, my understanding of that. And I kind of just said all of that without the slides, but I just real quickly wanted to talk about smart contracts before we turn off this recording and just open it up to questions for everybody. I thought this was really interesting. And this is something you really have to kind of go dig into chapters 6 and 7 of Mastering Bitcoin to kind of read up on and understand. But we a lot of times when people use the word smart contract, they really associate that with ETH and stuff like that. But we do have smart contracts on Bitcoin. I want to talk real briefly about how that works. So in Bitcoin, we have something called a locking script that defines what conditions are necessary to spend an output, right? And just as a basic example, I could make a locking script for a Bitcoin transaction to where anybody who can solve x plus 3 = 5, anyone who could solve for x could spend that output. And that's what the opcode, the locking script would look like for that. If you looked up the transaction in a block explorer. This is a terrible locking script. I don't know why you would do this, because anyone who can solve this simple, algebra problem can spend that output. But that's the most basic example of a locking script. And then if you wanted to do something a little more standard, this is a typical UTXO. You're saying, hey, anyone who can, provide a digital signature for this public key hash can spend this output. That's what you see abbreviated as P2PKH, pay to public key hash. Really obnoxious acronym, but it is what it is. So that's a kind of a standard locking script. Then you have a multisig UTXO, and as you see, these locking scripts start to get more and more complicated the more stuff you have to add into them, and that's an example of a 2 of 3 multisig. The magic happens though, where you can make these locking scripts as complicated as you want, as long as you as the developer learn Bitcoin opcodes and you learn how to chain these in a way that does what you want them to do. This is my understanding of it. I'm probably, I'm sure someone like Steve probably, has a lot more to say about something like this. But the way I understand it is you could write an incredibly complicated locking script, generate a hash of that, and then you just include in the transaction this pay to script hash thing. And I think, really, you could write very, very complicated locking scripts if you want. And the way I understand it is that Lightning is taking advantage of this feature and the whole idea of the revocation secret and the punishment transaction. My thinking is that happens in here. In this script hash, and that's kind of this would be an example of how a smart contract could be written on Bitcoin and used in a really clever way with Lightning. So I might have gotten some of that wrong, but I just wanted to open up that discussion around Bitcoin and smart contracts. And I think this might be a good place to cut off with chapter 3 this week, save some of the other topics for next week. And at this point, I think, does anybody have anything they'd like to say that should go in the recording before I turn it off and open it up for free unmonitored discussion? Okay, I'm going to take that as a no. So I'm going to go ahead and stop the recording, and then we can just kind of have a free open discussion around this chapter, and people can hang out in the Jitsi as long as they want to and talk about this stuff.
Just
All
want to
right.
say thank you, Steve. This was Steven. This was really cool. Big presentation. Good, yeah. Lots of effort put into this.
Yeah,
That was very
yeah,
nice.
great,
Oh, thank you.
great presentation.
I have a question. Was my screen actually being shared for that last bit there about the smart contracts?
Yes.
Okay, cool. Just making sure. So I'll post that online like later.
We're still recording.
Is it? I thought that I had. Well, hold on a second. I think you're right, Alexa. I think I stopped the screen share, but not the recording.